So in this lesson, we're going to now do another type of histogram. And really, we're going to take work that we've done in problem 1.2, B1 and 2, and we're going to look at another way to count the number in each interval. And so if you look at these, we just counted the number 1, 2, 3, 4, 5, 6. There's 7 in this interval between 60 and 74 natural peanut butters. But there's another way to look at it. Instead of counting, it's called the relative frequency. And it's calculated as a percent of the total number of these quality ratings. So if you count all these X's here for natural peanut butter, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So there's 14 marks in here, 14 quality ratings. One of them out of 14 is in this set. Another 1 out of 14 is in this set. 1, 2, 3, 4, 5, 6, 7 out of 14, which is half of them, are in that set. 3 out of 14 here, 1 out of 14 here, and 1 out of 14 here. So what I want to do now is I want to take these fractions of 14 and change them to percents. And I'm going to change my lines up here. Instead of counting, I'm going to go by percent. So let's just think of this as if this was 0%, and then we went by 10. So 10%, 20%, 30%, 40%, 50%. And so the height of my bars is going to be equal to the percent of the data in that. So some of these I'm going to need a calculator to do a little of the percent calculating. So if I have 1 out of 14, so to find the percent, 1 divided by 14, that's how you find a percent, and that gives me 0.071, which is 7%. You take a fraction, 1 divided by 14, and then multiply that number times 100, or move the decimal point 2 places to the right, and so it gives you 7.1%. So these here represent 7.1%, and there's another one there, 7.1%. And so 3/14, 3 divided by 14, represents times 100 will give me the 21.4%. So again, all I'm doing is changing these from counts to percents, percent of the whole data. So we're really kind of now percentizing, if that was a real word, changing these into percents, percent of the data that's in each bar. 7% of the data is here, 7% is here, 21% is here. 7 out of 14 is half. 7 divided by 14 gives you half, which would be 50%. So this is 50%. And then again, we've done 1 divided by 14 already. That's 7.1%. And so is this. And so now all I want to do is take these numbers, these percents, and transfer them up to my graph above. So now I can take the 7%, which is just a little less than 10%. And so now I'm going to actually kind of make a bar graph here. Still a histogram because we're just keeping track of the data by what's in there. And this one is the same, 7.1% in the 40 to 49 interval. And then we're at 21%, so 20, 10, 20, a little bit beyond there. 21% in the 50 to 59 interval. And again, we're kind of making it now look more like a bar graph. And then 50%, all the way up to 50% in the 60 to 69. And again, we're just changing things over to percent so that we can kind of see the data more in terms of what percent of the data falls in any one particular interval. And you can see that half of the data, 50%, falls into this interval from 60 to 69, and then we have 7.1% in here and in the last one as well. So these two have the same, just under 10% on my lines. And so now we have a kind of another way to look at the quality ratings. These are the quality ratings for natural peanut butter. And again, now they are as a percent of the data. And it doesn't look a whole lot different from what we've done so far. It's just, again, another way to look at it. If we're looking at a percent frequency, we call it a relative frequency, relative to the whole data. So this ends up being what we call relative frequency. As opposed to a count frequency. Now we want to do the same thing with the regular peanut butters, because then we have something that we can do that with. And so I'm actually going to go ahead and use the data that I did in this one to do that. But it's going to be a little bit tricky because I want to go in sets of 10. So I'm going to actually take, so up to this point here, so I've got 1 here out of all of these, and there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So that's 1 out of 23 in the 10 to 20 interval. So this whole interval right here. So right there, I'm going to actually kind of group them together. And then here's 4, these 4 out of 23 there for the regular peanut butters. And then the 30 to 40 interval, we got 1, 2, 3, 4, 5, 6 out of 23 in this set here. And then 1, 2, 3, 4, 5, 6 out of 23 in the next set of 10, or interval of 10. And the only reason I'm doing intervals of 10 now is because I wanted to use the same interval spread that I used in the original one above. And we have 2 in this set out of 23, those 2, and then 1 out of 23, and then in the 70 to 80, 1 out of 23, and then the last set there where the 80s are, you have 2 out of 23. And so now I need to turn those into percents so that I can use those for relative frequency. So 1 divided by 23, and I can multiply it by 100 if I don't know how to move the decimal point. So it's about 4.3%. And then 4 divided by 23 is 17.4%. And 6 divided by 23 is 26%. So we have 2 of those, 26% of the data is right here. Another 26% is in this section. And then 2 out of 23 is look like about 8.7%. We're going to end up rounding these off anyway when we put them in the chart. And we've already done 1 out of 23, which is 4.3%. And another one of those. And then the 2 out of 23, which we already did, is 8.7%. So now we have them all as percents. And so now I want to transfer that onto a histogram using percents. So as a percent count or a percent frequency, so we're going to use percent here, which is relative frequency. And so 0, 10%, 20%, 30%. And I already noted that on my chart the highest percent is 26, so that's really as far as I need to go with percents. So in the 10 to 20 interval, it looks like I have 4.3% less than 5%, so it's a fairly low percentage in this interval, so less than half. And in the next interval, 17.4%, so almost 20%. Again, I'm estimating a little bit because I'm using percents and my chart doesn't go very high. I maybe could have helped myself if I'd gone 5, 10, 15, 20%, but we're going to keep it the same as the other one just so we can see how it compares. The one we did with natural peanut butter. And the next one, in fact the next two are both 26% each, so about halfway there. Same with the next one, they're even. So these two at 26%. Again, these start to look more like we can think of as a bar graph. A bar graph is really a type of histogram. We're just keeping track of data, though there are other uses for bar graphs. And the next one is, next interval, 50 to 60 is 8.7%, so under 10%. And then another 4.3%, so very little, less than half. And another one, less than half. And then another 8.7%. And then these are the regular peanut butter quality ratings. As a percent of the whole data, so you see that in this section here, 26% of the regular peanut butters fall in this interval, another 26%. So really you have over 50% of the regular peanut butters falling into these two intervals. And that goes back to what we said in the very beginning, that most of the regular peanut butters are in the 30 to 50 range. So again, it's just another way to look at it and another way to compare, because we can compare this one to this one now, and they're both written as percents of the totals. And you can see how kind of the data, well, just pretty clearly that the quality ratings of the natural peanut butters in general clusters higher as a percent of the data than the regular peanut butters. The whole point of these graphs oftentimes is to be able to make comparisons. So we could say, maybe as a general idea, that the quality of natural peanut butters based on these histograms, either using relative frequency or using our regular sort of histogram count. You see how these are kind of using these for work, that either way, see that the regular peanut butters tend to cluster down here in the 30 to 50, and the natural peanut butters data clusters up much higher in the 60 to 70 range. And again, that shows in all of our histograms, regardless of the ways that we do it. But these are using relative frequency instead of just a frequency count. It's a different way to keep track. A little more complicated, but still, if you understand the idea that each of these intervals has a certain number of data points in it, and you can find the percent of the entire data by taking that number divided by the whole, just like you would find the percent of any number. And that covers how to make a relative frequency histogram for these data.